Well, good morning, Friday. I'm really hoping this is my last video lesson. I do have them prepared for next week in case, but I'm really hoping that to be back next week. Was disappointed that I'm not back this week, but well, we'll all see what happens. We're going to start talking about the graphs of other trigonometric functions. Oh, look at that. The T's not capitalized. Oh, that's annoying. Oh dear, too late. And I want to take a look at what can we do and what do we know about graphs of the other trigonometric functions. Tangent, cotangent, secant, and cosecant. All right, so let's take a look at this and let's attack this the same way we did sine and cosine. So I want to know what is y equals f of x equals the tangent of x. So I'm going to create a data table and let's graph it from negative 2 pi to 2 pi. And we know we're going to need our little unit circle here. It's going to help us with the values. No, that's not a very good unit circle, is it? Oh, well. And I know that this is going to be 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. I also know the coordinates. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And let's create our table now. Let's take a look at the table and fill it all in. So we're going to have x values and the tangent of x. And we're going to go from negative 2 pi to 2 pi. So negative 2 pi, negative 3 pi over 2, negative pi, negative pi over 2, 0 pi, positive pi over 2, positive pi, 3 pi over 2, and 2 pi. Now tangent, how do we know what tangent is? Well, we know that tangent opposite over adjacent. Tangent is the y value over the x value. So as I take a look at tangent here, what is going to be the tangent at 0? Or at negative 2 pi rather, negative 2 pi. But we can see that that negative 2 pi and 2 pi are really going to be the same thing, aren't they? Well, it's going to be the y value over the x value, 0 over 1, which is 0. How about negative 3 pi over 2? So negative 3 pi over 2 here. Y value over the x value, 1 over 0. 1 over 0. Wait a minute. 1 over 0 is a problem. 1 over 0 is undefined. How about at negative pi? Well, at negative pi, I'm again going to have the y value over the x value. I'm going to have 0 over negative 1, which is 0. At negative pi over 2, I'm going to have negative 1 over 0, which is undefined. At 0 pi, I'm going to have 0 over 1, which is 0. At pi over 2, 1 over 0, which is undefined. This is not looking very good. At pi, I'm going to have 0 over negative 1, which is 0. At 3 pi over 2, I'm going to have negative 1 over 0, which is undefined. And at 2 pi, I'm going to have 0 over 1, which is 0. Well, gosh, it doesn't seem like there's a lot of information here. Can we graph this? What would a graph of this data look like? I'm going to put negative 1 and positive 1 there, even though I know I don't see any negative 1s or positive 1s over there. And so let's see, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And let's see what happens here. Well, negative 2 pi, it's 0. I can graph that. That's 0. 0, 0. But negative 3 pi over 2 is undefined. How do you graph undefined? What does it mean? Well, undefined slope means that that the tangent is not defined here. This is going to turn out to be that it's not part of its domain. How am I going to show that? I'm going to show that with an asymptote. It's not defined. At negative pi, it's 0. Negative pi over 2, again, undefined. So I'm going to show that with an asymptote. At 0 pi, it's 0. At pi over 2, undefined. Again, I'm going to show that with an asymptote. It doesn't exist there. At pi, it's 0. 3 pi over 2, undefined. I'm going to show that again with an asymptote. And at 2 pi, it's 0. Oh gosh, how do we connect the dots? What's going on here? I mean, what do I, what does this look like? Now these lines are do not cross lines. I can't cross them. There's no holes. So when I think about what happens, what's happening here? What's happening specifically from here to here? I know I've got the origin here. Well, it's either going to run up the asymptote or run down the asymptote. It cannot cross the asymptote. How do I know which it is? Well, 0 to pi over 2. That's the first quadrant. Those are all the angles in the first quadrant between 0 and pi over 2, first quadrant. And in the first quadrant, tangent is positive. All of my values are positive here. So this has to be positive. So the only thing it can do is run up the asymptote. What about over here? Pi over 2 to pi. Pi over 2 to pi would be the second quadrant. Tangent's negative. All the angles here are negative. It has to look like this. Between pi and 3 pi over 2 is the third quadrant. Tangent's positive here. It would have to look like that. Between 3 pi over 2 and 2 pi, that's the fourth quadrant. Tangent's negative there. It would have to look like this. What about over here? Between 0 and negative pi over 2, 0 and negative pi over 2, that's the fourth quadrant. Tangent's negative. It's going to look like this. How about here? Negative pi over 2 to negative pi. Negative pi over 2 to negative 2. This is going to be this quadrant right here, the third quadrant. Tangent's positive there. Here, this would be the second quadrant. Tangent's negative. And here, this would be the first quadrant. Tangent's positive. So there it is. There's my tangent. There's the graph of tangent. All right, so let's talk about it for a moment. Domain, range. What can we tell about these things, about the domain and range of it definitely has the domain is not all real numbers. It has domain restrictions. It cannot be pi over 2 or 3 pi over 2 or negative pi over 2 or negative 3 pi over 2 or 5 pi over 2. So my domain, I want to make a special note about this. The domain x's cannot equal pi over 2 and every pi after that. So I'm going to write pi n, where n is an integer. So pi over 2, and then when n is 1, that would be another pi later, 3 pi over 2. When n is 2, 5 pi over 2. Or if n is negative 1, I'd get negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So there's my domain. I have a bunch of domain restrictions. How about the range? What's the range on tangent? Well, you can see there is no maximum or minimum as I run up and down those asymptotes. The range is going to be all real numbers. So there's tangent. All right, let's take a look now at cotangent. We're going to do the same thing. Y equals f of x, the cotangent of x. And I'm going to graph it from negative 2 pi to 2 pi over that interval. Let's use our little unit circle here to help us do the actual calculations. It's always a good thing to think about this unit circle. I've got 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And I know all the coordinates in here. This is the coordinate 1, 0. This is the coordinate 0, 1, negative 1, 0, and 0, negative 1. Let's create our data table now for graphing. And I'm going to have x values and cotangent of x. And we're going to have negative 2 pi, negative 3 pi over 2, negative pi over 2, 0 pi, positive pi over 2, 3 pi over 2. Wait, I forgot one, didn't I? Pi over 2, that should just be pi. That should just be pi. This is 3 pi over 2 and 2 pi. All right, so let's see what happens here. So now cotangent, I can think about it as the inverse, or 1 over the tangent. I could also think about it as the y values over the x values. But so here, the tangent at negative 2 pi was 0. 1 over 0 is undefined. Here, this was undefined. Negative 3 pi over 2, I'm going to have 0 over 1, which is going to be 0. And at negative pi, undefined. Here, at negative pi over 2, it's going to be 0. At 0 pi, it's going to be undefined. At pi over 2, it's going to be 0 over 1, which is going to be 0. At pi, I'm going to have negative 1 over 0, which is undefined. At 3 pi over 2, I'm going to have 0 over negative 1, which is 0. And at 2 pi, I'm going to have 1 over 0, which is undefined. So again, it looks very similar. We can see the same kind of situation is going to happen here. Let's graph this thing and take a look at it and see what it looks like graphically. Negative 1 and positive 1, and pi over 2, pi, 3 pi over 2, and 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And again, everywhere I see this undefined, I've got an asymptote here, 0, an asymptote, 0, an asymptote, 0, an asymptote, 0, an asymptote. And I'm going to have to use the same trick now, and I think about this. So if I look here in this quadrant right here, what's going on here? Well, between 0 and pi over 2, between 0 and pi over 2, here it is. So is cotangent positive or negative there? Well, tangent is positive, therefore 1 over a positive number is still going to be positive. It's positive here. It can't cross that axis, so it has to run up that axis like this. Here's the second quadrant. Tangent is negative, therefore cotangent is negative. Here's the third quadrant. The third quadrant, tangent is positive, so cotangent is positive. Fourth quadrant, tangent is negative, therefore cotangent is negative. This is also fourth quadrant, isn't it? 0 to negative pi over 2, 0 to negative pi over 2, fourth quadrant here. Tangent is negative, so cotangent is going to be negative. Here in the third quadrant, tangent's positive, cotangent is going to be positive. Here in the second quadrant, tangent's negative, cotangent's negative. And in the first quadrant, tangent is positive, therefore cotangent is positive, and I get this graph right here. All right, so again, very similar. let's compare them, put them on top of each other, and take a closer look at them. So here they are, one on top of the other. And again, I want to make sure that we know that this is tangent of x, and this is cotangent of x. Notice, everywhere that tangent is 0, 1 over 0, its inverse is an asymptote. Here it was 0, 1 over 0 is an asymptote. Now take a look, because these are not just phase shift. Remember sine and cosine? With sine and cosine, remember how we could kind of slide them and get them to be the same? That's not going to happen here, is it? It's never going to be the same. So not only is there some sort of translation going on, but there's also some sort of reflection that's going on as well. The domain, again, is restricted for cotangent. It's I can't have 0 pi or 2 pi or 3 pi. So let's write down the domain restriction here. The domain, M-A-I-N, x's cannot equal pi times n. So 0 pi, 1 pi, 2 pi, 3 pi, or negative 1 pi, or negative 2 pi, or negative 3 pi, where n is just some integer. So those are my domain restrictions. So tangent and cotangent, very similar graphs, but very different. Not an awful lot of applications for what we're doing in with tangents and cotangents here. All right, I'd like to continue now by taking a look at secant and cosecant. So let's take a look at y equals f of x equals, let's start with the secant of x. And one of the ways of thinking about the secant of x might help us a little bit, is thinking about it as 1 over the cosine of x. And let's graph it from negative 2 pi to 2 pi. Let's get our little unit circle here to help us with the calculations. And as I take a look at this, I know my angles, 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. I know my ordered pairs. This is the coordinate 1, 0. Here is 0, 1, negative 1, 0, and 0, negative 1. And we're going to create our table now. X values and secant of x. And again, when I think about secant, I'm really thinking about the inverse of cosine, 1 over cosine. So we're going to go from negative 2 pi, negative 3 pi over 2, negative pi over 2, 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. So if I plug in secant. Now, as I do these, I'm really going to be thinking about, well, what's cosine? And then I'm going to put 1 over that. So if I look at negative 2 pi, start here and go negative 2 pi, there it is. What's the cosine at negative 2 pi? Cosine is the x value, so it's 1. 1 over 1 is just 1. How about negative 3 pi over 2? Start here, negative 3 pi over 2 here. What's the cosine there? The cosine is 0, so the secant would be 1 over that. 1 over 0, and that's undefined. So we're seeing undefineds now again here. How about at negative pi? The cosine is negative 1, so the secant would be 1 over negative 1, which would be negative 1. Negative pi over 2, the cosine there would be 0, 1 over 0, undefined. At 0 pi, the cosine is 1, 1 over 1 is 1, secant, remember. At pi over 2, the cosine is 0, So the secant, 1 over 0, would be undefined. At pi, the cosine at pi is negative 1. 1 over negative 1 is negative 1. At 3 pi over 2, the cosine is 0. 1 over 0 is undefined. And then at 2 pi, the cosine is 1. 1 over 1 would be 1. Now let's see. What's the graph of this thing going to look like? Oh, that wasn't a very good straight line, was it? I notice I've got negative 1s and 1s here again. 1 and negative 1. So pi over 2 pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. At negative 2 pi, it's 1. So that's right here. At negative 3 pi over 2, undefined. So I'm getting an asymptote. At negative pi, it's negative 1. Negative pi over 2, undefined. I'm getting an asymptote here. At 0, it's 1. At pi over 2, it's undefined. I'm getting an asymptote here. At pi, it's negative 1. So trying to emphasize these points. 3 pi over 2, undefined, another asymptote. And at 2 pi, it's positive 1. Now, I can't connect these dots, right? You can't cross these asymptotes. So we're going to use the same trick we did with tangent and cotangent and say, well, what's happening? So in this example right here, in this part right here, I know it's 1 here and there's an asymptote there. Could it go down and run down the asymptote? And the answer is no. Why not? Because there would be an x-intercept. And there aren't any x-intercepts. There are no x-intercepts here whatsoever. In this first quadrant, cosine is positive. Secant is 1 over cosine. 1 over positive is a positive. So it has to be positive here, and it cannot cross the x-axis. The only thing it can do is that. What about here in the second quadrant? Cosine is negative. Therefore, secant, 1 over negative, is going to be negative. It cannot cross there, so it has to go down like this. How about here? In the third quadrant, again, cosine is still negative down there. So 1 over a negative number is going to be negative. Here, this represents the fourth quadrant from 3 pi over 2 to 2 pi. And cosine is positive here. This would also represent the fourth quadrant, positive here. Here is my third quadrant. Cosine is negative. Second quadrant, cosine is negative. First quadrant, cosine is positive. So there it is. I get this very strange looking graph. Notice that there are no x-intercepts at all. None. None. What's the domain? Is it all real numbers? No, there's a bunch of restrictions. Pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So my domain, the x's cannot equal pi over 2 plus pi n. So pi over 2 plus every pi after that, or minus every pi after that. That's my domains, my domain restrictions. My domain cannot equal that. What's my range? The range is a little bit more interesting. My range, it looks like I've got from negative 1 going to negative infinity and positive 1 going to infinity. So from negative infinity to negative 1, including negative 1, and from 1 to infinity. So that's a little bit more interesting, what's going on here with secant. Next, we're going to take a look at cosecant, and we're going to use the same trick as 1 over sine, but hold on to this, because I'm going to come back and we're going to add something to this a little bit later. So I'm going to put this aside, and yes, we'll compare them, but then we'll add something a little bit later. All right, so here we go. So the last one we want to look at is y equals f of x, which is the cosecant of x, which we also know is the same thing as 1 over sine. So while I'm doing this in my head, I'm really going to be asking myself, well, what's the sine value? And then 1 over that would represent the cosecant. We're going to do it over the same interval from negative 2 pi to 2 pi. Let's draw my little helper. Hopefully we're getting to the point where we can kind of think about this without even drawing it anymore, and we're thinking about these angles in our head. We can see them. We can see all the points. 1, 0, 0, 1, negative 1, 0, 0, negative 1. In fact, I think this might be the last time I put that up there as a helper, but definitely something we'll refer to and talk about, and helps us to think and organize the information. So we'll leave a little room for domain and range here in a moment, and we're going to pick some x values, and we're going to calculate the corresponding cosecant of x from negative 2 pi, negative 3 pi over 2, negative pi over 2, 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so let's see. We know that the sine of x, we're thinking mostly about the y values when we look at that. So at negative 2 pi, so if I start here and I go negative 2 pi, what's the y value right there? The y value is 0. So 1 over 0, that would be the cosecant. That's undefined. How about negative 3 pi over 2? Negative 3 pi over 2 is right there. What's the y value? 1. So 1 over 1 is 1. How about negative pi? What's the y value? 0. So 1 over 0, undefined. How about negative pi over 2? It's negative 1. 1 over negative 1 is negative 1. How about 0 pi? The y value is 0, or I should say the sine of 0 pi is 0. 1 over 0, undefined. Pi over 2, 1. 1 over 1 is 1. At pi, 0. 1 over 0 is undefined. 3 pi over 2, I get negative 1. 1 over negative 1 is negative 1. And at 2 pi, I get 0. And 1 over 0 is undefined. All right, so now let's graph this one. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, so let's see. At negative 2 pi, undefined, asymptote. At negative 3 pi over 2, 1. At negative pi, asymptote, undefined. At negative pi over 2, negative 1. At 0 pi, undefined, asymptote. At pi over 2, positive 1. At pi, undefined, an asymptote. At 3 pi over 2, negative 1. At 2 pi, undefined, an asymptote. So again, doesn't seem like I know much here. Let's kind of start breaking this thing down. Let's look right here. First quadrant, 0 to pi over 2. 0 to pi over 2. Sine is positive, therefore cosecant is positive. So it has to be positive in here. It's not going to cross. There's not going to be any x-intercepts. This is the first quadrant. It's going to be positive. Second quadrant, sine is also positive, therefore cosecant is positive. In the third quadrant, sine is negative, therefore cosecant is negative. Fourth quadrant, there it is. Sine is negative, therefore cosecant is negative. This is the fourth quadrant as well, negative. Third quadrant, negative. Here's the second quadrant, sine is positive. First, sine is positive, and there it is. So again, let's lay these on top of each other and take a look at them. Are these phase shifted? If I moved one over, could I get the other one? Let's see. If I took let's write down what each one of these is, so we make sure we can keep track of them. Remember, this is secant x, and this is cosecant x. If I took secant and moved it over pi over 2, would it be the same? Yeah, I think it would. They would, wouldn't they? They really would. They are phase shifted of each other. How about the domain and range? What's the domain and range of cosecant? I've got restrictions at 0 pi, pi, 2 pi, negative 2 pi. So my x's cannot equal pi n. So any number integer times pi. What about my range? Is the range the same as secant? Yes, I think it is. From negative infinity to negative 1, including negative 1, and then from 1, including 1, to infinity. All right, there they are. Now, I said I was going to do something a little bit extra here. And I don't know if I want you to do this in your notes, but I just want you to watch this. So I'm going to start with cosecant. Now, cosecant is 1 over sine. So here is cosecant. What I'd like to do is I'm going to graph sine on top of this. So if I graph sine on top of this, there it is. That's sine on top of cosecant. Take a look at that. Anywhere where sine is 0, cosecant has an asymptote. Sine is 0, cosecant has an asymptote. Can you kind of see a connection here? The same thing happens with secant. Here I have secant, which is 1 over cosine. If I sketch cosine on top of this, and again, I want you to see that, now the yellow highlighter is cosine. Wherever cosine is 0, 1 over 0, secant is undefined. Wherever cosine is 0, 1 over 0, secant is undefined. But then kind of take a look at how they connect and the connections between them. The other thing that I want you to do is play around on your calculator. How would we graph secant on our calculator? There is no secant button. There's the key, 1 over cosine. So what I'm going to do is I'm going to graph cosine, the cosine of x, and I'm going to go to zoom trig, which is 7. So here is regular plain old everyday cosine. We should know that pretty good. Good old cosine, there it is. Now I want to graph secant on top of it. How do I graph secant? Well, I'm using the reciprocal rule. 1 divided by the cosine. 1 divided by cosine, that's secant. So now here comes secant on top of it. And I think we can see that where the cosine is 0, I'm getting the asymptotes in the secant. Kind of a really cool connection there. Same thing happens with sine and cosecant. And play around with it on your calculator. Do a whole bunch of different ones on the calculator. So this was the only lesson for today. And then you're going to go ahead and work on the homework from 6.5. It's going to ask you to kind of play around with a bunch of stuff, looking at things, talking about domain and range. Yes, we can shift these things left and right and up and down and change the amplitudes and phase shifts and center lines and all that crazy stuff, but we're really not going to do much at all with these things, with these other ones. Tangent we'll see once in a while, but these other ones, yeah, we're not going to do much with them at all. So don't stress about all the crazy stuff we're doing with sines and cosines. We're not going to do that with these. All right, well, good luck, and I will hopefully see you on Monday.